Hey everyone, and welcome to The Explainer. Okay, let's dive right into this. When you hear the phrase buying software, you probably think about, hopping onto an app store, tapping a button, and waiting a couple of seconds for a download. But in the world of large-scale software engineering, buying software is an entirely different beast. We are talking about multi-million-pound decisions that dictate the entire trajectory of an organization before a single line of code is ever written. Today, we're going to explore this high-stakes environment in a masterclass explainer on Section 19.3 of Ian Sommerville's software engineering textbook. We are looking at System Procurement.
So here is a quick look at the syllabus for today's program. We'll be covering an introduction to procurement, the business drivers behind it, the three distinct procurement paths, Glueware and Principal Contractors, the risks and politics involved, and finally, a wrap-up summary for your exams.
All right, Part 1, Introduction to System Procurement. What exactly are we actually buying here?
Let's start with a solid definition. System procurement, which is sometimes called system acquisition, is the process whose outcome is a decision to buy one or more systems from suppliers. Now, notice that it's not just the simple act of swiping a credit card. It's the extensive, complex decision-making process leading up to that purchase. At this conceptual stage, you're making high-level decisions regarding the scope of the system you want, the budgets you have available, the timescales for delivery, and the high-level system requirements. Basically, you are defining the absolute boundaries of the project long before the developers actually get to work.
Moving right along to Part 2, the drivers of procurement. Simply put, why do companies decide to spend millions on new systems in the first place?
Well, according to Sommerville, there are 5 main business drivers, plus one highly influential hidden driver. First up, replacing old legacy systems. If an organization is running a messy mix of outdated systems that just can't communicate and cost a fortune to maintain, a new system brings immense business benefits. Second is external regulations. Businesses often have to prove compliance, like with these Sarbanes-Oxley accounting regulations over in the US, which might force them to buy entirely new monitoring systems. Third, external competition. You buy new systems to improve efficiency and just stay ahead of your rivals. Fourth, business reorganization. When a company restructures, its internal processes change, demanding new system support. And fifth, the available budget simply dictates the scope of what can actually be procured. But here is the really crucial point. There is a sixth, massive driver: political policies. For example, politicians might procure a shiny new surveillance system simply to demonstrate to voters that they are taking action on security. It's not always about technical need, right? Sometimes it's purely about political optics.
Okay, on to Part 3, the 3 procurement paths. Now that we know why we buy, how do we actually go about buying it? Take a look at this flowchart, which brilliantly illustrates the 3 distinct paths you can take. Notice how all 3 paths start all the way on the left with conceptual design, but then they diverge completely. The top path is for off-the-shelf systems. You assess approved applications, select one, and simply place the order. The middle path is for configurable systems. You do a market survey, create a shortlist, choose a supplier, negotiate a contract, and, this is key, you modify your own requirements to fit the system. And then the bottom path is for custom systems. You must define really detailed requirements first, issue a formal request for tender, choose a supplier based on their bids, and then negotiate a heavy, complex contract. Let's break these down just a bit further.
Let's directly contrast that top path and the bottom path. Off-the-shelf applications are fast and, relatively speaking, cheap. Often large organizations have a pre-approved set of software already checked out by the IT department. So if you need a blog, you just select WordPress from the list, buy off-the-shelf microphones, and boom, you are done. The users adapt to the system. On the complete other extreme, we have custom systems. These are built from scratch, meaning they are slow and incredibly expensive. You can't just place an order. You have to write out a highly detailed requirements specification. And why is that? Because that document actually becomes part of a legally binding contract between the buyer and the supplier. Plus, regulations often slow this whole thing down. In the European Union, for instance, public sector systems over a certain price tag must be opened up to tender across Europe for a fixed period. This legally forces you to develop incredibly detailed requirements up front so that any company can bid on it, which entirely inhibits fast, agile development.
And then we have the middle ground, configurable applications, which are often known as enterprise resource planning, or ERP systems. Think of massive systems from companies like SAP or Oracle. You don't build them from scratch, but you certainly don't just plug them in either.
After choosing a supplier and negotiating a contract, you hit a pretty significant hurdle. Off-the-shelf components rarely match your exact needs perfectly. So what happens? You actually have to modify your own business requirements to fit the software's built-in assumptions. You literally have to undergo an extensive configuration process to adapt this broad, generic system to your specific working environment.
Let's do a really quick recap of this vital concept, just to solidify it before we move forward. Off-the-shelf is fast but inflexible, you get what you get. Custom is perfectly tailored to your needs, but it is expensive, it's slow, and it's bogged down by legal contracts and tender regulations. And the ERP middle ground? It gives you a powerful base system, but it demands that you actually bend your business processes to fit the software, which can be incredibly disruptive.
Moving into part 4, Glueware and Principal Contractors. Basically, how do we assemble all these pieces?
This brings us to a frankly fantastic term, Glueware. Large, complex systems are usually engineered using a crazy mixture of off-the-shelf components, specially built components, and old legacy databases. And spoiler alert, they don't just magically talk to each other. You have to write custom software to manage the interfaces so these separate components can actually interoperate. This is called Glueware. And I have to warn you about a massive risk here. Companies often buy off-the-shelf components thinking, oh, this will be so cheap, only to discover they need to write so much custom Glueware and then absorb the ongoing maintenance and testing costs of all that code that the anticipated financial savings are completely wiped out.
So, who actually builds all this? Complex socio-technical systems are almost never developed in-house by the buyer. A hospital simply doesn't have the internal skills to build a medical record system, so they invite external companies to bid. Now, for an immense system, let's say a national air traffic control system, you need computer hardware, software, specialist radar equipment, peripherals, the whole shebang. Customers absolutely do not want the headache of negotiating with 10 different suppliers, so the contract is awarded to a Principal Contractor. This is a single company that takes charge of the entire project. They manage the consortium, they coordinate all the various subcontractors, they integrate all those subsystems, and they deliver one final, cohesive product to the buyer.
Part 5. Risks and Political Factors. Or, what happens when things inevitably go wrong.
£10 million. The textbook outlines a real-world system failure where an organization made a terrible procurement decision. Management decided to procure a large-scale ERP system because they really wanted to standardize operations across their entire organization. However, the organization was incredibly diverse, and for very good reason. Standardization was practically impossible. The ERP system simply could not be adapted to cope with the company's natural diversity. The project was ultimately abandoned, but only after incurring costs of around £10 million. This highlights how a single flawed procurement decision at the very beginning of a project can doom it to an expensive failure. And hey, it also impacts security. If you buy off the shelf, you are entirely at the mercy of the vendor's security decisions and any known weaknesses in their product.
And this perfectly illustrates a great point, captured by this quote from Sommerville. Many bad procurement decisions stem from political rather than technical causes. You see, sound engineering logic doesn't always win in the boardroom. Senior management might demand a single system just to exert more control over the organization. Suppliers might win a bid not because their technology is actually the best, but because they have a long-standing, cozy relationship with the executives. Or managers might stubbornly demand compatibility with outdated legacy systems simply because they feel threatened by new technologies. Procurement is as much about navigating human behavior as it is about software engineering. All right, we've made it to part 6, the lecture summary and exam focus.
Listen up, because here is your exam focus for this module. First, ensure you can define procurement. It's the decision process involving scope, budgets, and high-level requirements before development even starts. Second, know the business drivers, and definitely don't forget that hidden political one. Third, and absolutely most importantly, you must be able to contrast the procurement process for an off-the-shelf system versus a custom-built system. Remember those key differences in speed, cost, and legal documentation. Fourth, understand exactly why Glueware can wipe out your budget. And finally, recognize the Principal Contractor model and why it is used to minimize the management burden on the buyer when they're building complex integrated systems.
I want to leave you with a bit of a provocative thought to chew on. We've seen today that procurement is the crucial foundation of all software engineering. Every single decision made here locks you into a path. So, considering that £10 million failure we just discussed, how will the requirements you define or fail to define during procurement dictate the absolute success or failure of the next phase, system development? Think about that as we prepare for our next explainer. Keep learning, and I'll see you next time.